Hello, in this video we are going to present a biotechnology theme based on adolescent insemination forces with emphasis on cell escalation and the process involved in the preparation to carry out this technique. My name is Valentina Fernandez.
My name is Michelle Calle.
My name is Eric Adam.
Artificial insemination in mares is a reproductive technique that allows the transfer of semen from a stallion to a mare without direct mating. This method facilitates equine reproduction, allowing the crossing of geographically distant animals, reducing the risk of disease transmissions, and improving genetic selection. It is performed by collecting semen from the stallion, evaluating, processing, and depositing in the mare's reproductive tract during the most fertile period.
To perform the semen collection, we must have ready all the necessary implements for this procedure, besides trying to have a correct storage and conservation of the product. For this, it is essential to prepare the diluent, which is a preservative for the collected equine semen. The purpose of this diluent is to nourish the spermatozoa, to keep them in an environment without contamination, and finally to preserve them in an environment with optimum temperature, will be in transport, or finally to cryopreservation. The diluent is composed of glucose and other sugars provide energy and nutrition for the semen. Buffers such as citrate or phosphate to stabilize pH and protect the integrity of cell membranes. Antibiotics to avoid contamination or proliferation of pathogens in the zone.
Diluent preparation. Step 1. Add 100 ml of sterile water at 37 degrees to the contents in order to avoid thermal shock. Step 2. Homogenize the diluent. Step 3. Add 2 ml of ram cryoprotectant. Step 4. Homogenize. Step 5. Hold at a temperature of 37 degrees for about 10 minutes before adding to the equine semen. Step 6. Add the diluent to the equine semen slowly and gradually.
We are going to pretend that we are going to generate inseminated doses from this collection. In this case, our sample contains 70 million sperm per millimeter, according to the result of the new Bauer chamber, and 90 millimeters were collected of semen. That is, we have 6.3 billions of total of the sample. That is 70 millions divided by 50 millions equal to 1.4, this being our factor. We take this value and multiply it by the amount of semen collected. 1.4 per 90 millimeters divide this result by 10. And why by 10? Because the minimum inseminated dose according to Biotechnology in Colombia is 500 million sperm. That is, we will use 1,134 millimeters of standard for the 90 millimeters of semen, giving a total of 1,224 millimeters. From these 6.3 billions, we must take the viable percentage of this. In our case, is 62%. That is 3.9 billion sperm. That is divided by the amount of sperm in the inseminated dose. That is, it would be enough for 7.8 doses. It depends on you as a veterinarian if you decide to take that doses in whole numbers. That is 7 of 500 million sperm. The minimum inseminated dose discarding is 0.8, or adding it proportionally to each dose to use the entire collection. In 3.9 billion divided into 7 doses for a total of 558 millions per dose, and to have a higher ratio or effectiveness.
The collection of seminal sample was carried out with an artificial vagina type Colorado. This type of tool allows to obtain the same semen of the specimen
with characteristics similar to a ejaculate with natural mode, because they image the physiological conditions of the vagina of the mare, as pressure, temperature, and lubrication. This artificial vagina is composed of two chambers. The first chamber comprises from the outside to the latex container, into which water is introduced and a temperature. And the second chamber comprises the container in which the sample is collected.
The first, the water is heat. The temperature in the artificial vagina Colorado should be around 50 to 70 degrees Celsius to achieve thermal sensation of the lining is 14.2 to 14.5 degrees Celsius. This temperature range is important to achieve good stimulation on the sample and not higher, as it can cause injury to the animals, generate a possible rejection in the following procedures. Then the inside of the artificial vagina is lined with a slipper or semen sample box made of a low density polyethylene, which provides resistance of the time that friction of the penis is generated, and also by its particular shape of cone allows the correct flow of semen. The slider will then be lubricated using a rectal palpating glove to avoid direct contact with the slider. The lubricant must be special for artificial vagina of horses. The lubricant must be special for artificial vagina of horses. However, this is high cost. Then sample with pre-seminal fluid would be enough to lubricate natural the artificial vagina, since the use for other products to lubricate could affect the volume, pH, and sperm quality. And finally, the water is introduced with the ideal temperature into the artificial vagina. The temperature check should be done introducing the hand with the rectal palpating glove, and additionally, it should be checked that the pressure is uniform throughout the artificial vagina, that it does not hinder the penetration and complete erection of the penis.
Regarding the preparation of both the horse and the mare, the priority must be the safety of the operators who will be involved in holding the mare and collecting the semen, and ensuring the animal welfare by providing a comfortable and safe environment that does not put any of them at risk. To use ties or rope to tie or secure her limbs to prevent her from kidding and hurting the horse. And finally, it is recommended to bandage the female's tail for better handling at the time of collation. Regarding the preparation of the male, greater care must be taken. There are horses that are not as experienced in riding. Therefore, it is crucial to always have a completely calm environment that gives them a level of security to avoid accidents, especially for the person who is directing him. The horse must be led to the mare in order to detect her heat and allow an erection to be achieved.
The collection is usually performed using an artificial vagina to obtain a sample under controlled conditions.
Once the penis is exposed, it must be thoroughly but quickly cleaned to avoid losing direction. Therefore, it is necessary to have previously warm water and a neutral soap available. The water is poured generously but gentle, at the same time as washing with soap, exposing the guantes fossa for better washing. Always very gentle. Once this step is complete, the pins must be thoroughly dried with clean paper towel very carefully.
Stimulation and mounting. The equine must be stimulated by bringing him closer to the mare, so that he reaches an erection and proceeds to mount. After the collection, the semen should be handled with care, and care should be taken to preserve the avoiding temperature changes or manipulation that could affect the quality and damage the spermatozoa.
Then the filtration is carried out in order to remove possible contaminants and the gelatinous portion of semen, since the fraction is not rich in sperm and occupies a lot of volume. Then the filtration was carried out with filter paper inside of plastic bag, where the semen already filtered fell. In addition, normal with each color at the weight density at volume of 19 milliliters without the gelatinous fraction was observed. Volume itself does not have a positive correlation with fertility, but it is asked to calculate the total number of sperm, and color examination allows for the presence of blood, urine, of purulent material in the ejaculate.
When the semen is obtained, we proceed to perform an observation under the microscope to evaluate some essential aspects of the sample. This is done as soon as possible, and if it is possible to have a microscope on place of collection to have an initial analysis of its quality, in which we will first evaluate aspects at a general level.
Fertility allows us to observe if the spermatozoa in the sample have good movement, which can give an idea of the concentration and activity. This can indicate fertility problems in the sample. Later, it can be evaluated in a controlled environment. This first analysis is performed in order to be able to give us a first opinion of the viability of the sample for an eventual process of storage, preparation, and elaboration of straw for artificial insemination.
Sperm count allows to know the concentration of the ejaculate of the reproduced specimen. The parameter is important for the evaluation of fertility and also the profitability of the number of insemination doses obtained for each ejaculate. In this case, the count was performed in a new water chamber, which has 25 large squares of 1 per 1 millimeters and 16 small squares. The difference in this counting method is that the new water chamber requires the semen sample to be diluted first. The following steps were then followed. First, the semen sample needs to be diluted, then a ratio of 1:100 was performed. Then the microliters of semen was taken in 990 cubic centimeters, and the preparation was mixed properly. The new water chamber was then prepared, applying water to the edge so that the cover slip could be fixed. That micropipette was taken and the solution, semen and diluent, was applied by capillary action in the chamber. Next, the new water chamber was placed in the microscope with a 40x objective. The spermatozoa were counted, taking into account the spermatozoa with the complete head inside the frame. 5 quadrants were taken into account: upper left, upper right, lower left, lower right, and the middle quadrant. 74 were counted in the upper quadrant, 68 in the upper left quadrant, 72 in the lower right quadrant, 67 in the lower left quadrant, and 63 and 73 in the middle quadrant. Then the average was made by taking the total numbers of cells, which was 354, and dividing by 5, which equals the quadrant. The result was 70.8. Now, this average number of cells was taken, which was 70.8, multiplied by 100, which is the dilution factor, and finally multiplied by 10,000. This gave a concentration of 70 billion spermatozoa in 90 milliliters.
We proceed to take that semen sample for a more detailed evaluation. We perform the eosin-nigrosin staining, and this staining allows us to observe morphology and perform a viable and not viable cell count. First, we mix a drop of semen with a drop of eosin-nigrosin on a slide and generate a spread. Eosin stain dead spermatozoa in pink, while live sperm remains unstained. Nigrosin generates a contrast in the background to make the spermatozoa more easily visible. This staining is performed in order to make an analysis of a spermatozoa to evaluate the morphological condition, and this way we could define by counting those findings the quality based on a percentage that falls on the normality of abnormality of a sample. In the case of the semen collected by our team, it was found that the semen is not viable in the terms of percentage, having normal spermatozoa of 62% and a percentage of abnormality in this sample is 38%. Of the last percent, we evaluate the primary abnormalities being a total of 39.4% and secondary abnormalities of 60.5%. This semen, in our opinion, will not be able for a conservation process through straw or artificial insemination. This may be due to the age of the equine, since it is a young horse and this is its first collection. We can conclude that perhaps factors such as age or even diet may be involved in this percentage.
The process consists of the proper restraint of the mare, either in an stall or by tying her limbs with the intention of having a controlled environment, and bandage and elevation of the tail for better handling, and a thorough perineal cleaning with neutral soap, plenty of water, and drying with sterilized towels. In the semination procedure, a very gentle passage of the previously lubricated pipette is made through the cervical canal. Once the passage is complete, the syringe is loaded with the dose of semen, which must already be prepared at the appropriate temperature. The semen is disposed in the uterine body. After this, it is removed and the semination is complete by ejecting an ovulation inducer. It is not always necessary if it does not cause problems with the moment of ovulation. In the record of this process, the exact date and time of semination must be determined to make a periodic monitoring, confirming the pregnancy on the 15th of 17th day, and then confirm the stage of pregnancy again on the 30th or 35th day.
And finally, these are the prices of the elements that we use in this process.